So now that we've seen, there's kind of a basic example, done a simple walkthrough of an example of an argument. I want to look at a few more, right? A few more examples here. And before we do that, I've rewritten the process for validating an argument, right? We start with a truth table based on the premises and the conclusions. The premises get joined with an and we join the premises and the conclusion with a conditional. All right, so let's look at an example here. Right, kind of playing off of the driver's rules that most of us, I think, are familiar with. If you're over 15, then you can drive. You're under 15, therefore you can't drive. And I want you to think about that for a minute. Right, I want you to think about, just try to talk yourself through it. See if you can decide for yourself whether or not it makes sense, whether or not the argument's valid. Then we'll walk through it and see what the logical conclusion is. All right, so I'm going to start off the way we always start off. I'm going to let P be your over 15. I'm going to let Q be you can drive. All right, so let's do the logical versions now. If you're 15, then you can drive. That's P implies Q. You're under 15. That's not P. Therefore, so that's where my line is going to go. Therefore, you can't drive. Can't drive is not Q. Really made that longer than I needed. There we go. Okay, so now remember how we combine these together. These are the premises. This is the conclusion. So I'm going to join the premises with an and. So it's P implies Q and not P implies not Q. That's what I want to try to make a truth table for. All right, so let's see how we can do that. Right, I've laid it all out here. We're going to follow the same pattern we've been following. We're going to fill in P's and Q's. True, 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 false, false, true, and false, false. Excuse me. Then let's copy things over. Right? Let's see. This is going to copy the P's. True, true, false, false. Then I've got a Q that's true, false, true, false. Then this is a not P. So that's false, false, true, true. And finally, not Q is false, true, false, true. All right, so let's fill stuff in. Starting with a parenthesis, so this, the arrow comes first, right? And that is only false when I have a T and an F. So this one is false. These three are true. All right, so now we can cross these off, right? Those have all been simplified here into the middle column. Then I'm going to do the and. That's going to be this column and this column. So with an and, I'm looking for true and true. Right? That one gets to be true. Everything else is false. So this one is these two are true. These two are false. And again, now I'm done with this, and I'm done with this, and I'm going to do the final implication here, and that's going to be based on this row and this row. So remember, I'm looking for a T and an F. If I have a T and an F, that's going to be false. And I do have one right here. Everything else is true, but at this point, I don't care. Because remember, all it takes is one false line to render the entire argument invalid. So now I have the answer to my question. This is an invalid argument. In fact, this one is so invalid. Let me clean up here just a little bit. Some of these logical forms occur often enough that they have names. All right? This one, P implies Q and not P, therefore not Q. Right? This one has a name. This is called the fallacy of the inverse, right? Fallacy of the inverse. And if you try to think through this, right, here's why, if you can kind of try to follow me, this is why the argument is invalid, right? Remember, that implication doesn't tell me anything about what happens if the P part is not true. If the P part is not true, maybe the Q part is true, maybe it's not. It doesn't matter, right? For example, if you're under 50 in the state of Florida, where I live, if you're under 15, there's a weird law that it's a very agricultural state. So there's a law that says if you're under 15, you actually can drive an agricultural vehicle for short distances on public roads. Okay, so and that's kind of the problem with this. Like I said, it doesn't tell us anything about what happens if you're under 15. So we can't come to this conclusion based just on what we know. Okay, so let's try this again. Right, this is almost the same thing. I just made one change. Right, I just made one change. I changed it from if to if and only if. Right, let's see what that does. Now I'm going to use the same P's and Q's. So this will be P if and only if Q, not P, not Q. Right, and then here I've got the setup we can do our truth table. Right, you notice I've got, this is the first premise, this is the second, and this is the conclusion. All right, so let's do our usual stuff, right? I'm going to fill in true, true, false, false, true, false, true, false, and then I got a lot of copying to do. This is copying the P, this is copying the Q, not P is false, false, true, true, and not Q is false, true, false, true. All right, now the implication, or the biconditional. This one is true if both sides match. So true and false. Everything else is false. Now get rid of these two. And I'm going to do the and, right? The and is going to be based off of this column and this column. And it's an and, right? So this is the only place I have two trues. Everything else is false. All right, and then what? Now clean up again. I'm done with this column, and I'm done with this column. I'm going to combine these two into my conclusion. Do I have a T and an F? Well, I don't now, right? I don't. Now I have F's and F's, T's and T's. Everything here is now, everything here is now true. The argument is a tautology, which means in this case, we do have a valid argument. Right? So now you see both sides, right? You've seen what both valid and invalid arguments look like when we're working through the mathematical symbolic version. Okay, so what's next? We've got some more applications to look at, a few more examples, right? And that will wrap up this chapter.